So it turns out you've been lied to all your life, that the 220 volts or 110 volts is the maximum voltage. It's not true. Those are root mean square voltages. And that will be the first thing we are discussing, and then we're going to talk about also how to use those root mean squares in solving problems, which really isn't that difficult. So if you were looking at a graph of current and it's alternating, let's say you've got a light bulb plugged in. Your current is consistently going this way and that way and this way and that way, probably 50 to 60 times per second. And you might think, well, sometimes I have zero current, so maybe my average current, would it be just something like just a flat line through there? And your voltage, would that be a flat line? And if you again looked at the actual power you were getting from an alternating current source, sometimes you would be getting zero power, like 50, 60 times a second, because you'd have no voltage and no current. And so the average power, you couldn't actually look at your maximum. Instead, your average power would be somewhere around in here. And so you can't use those max currents. What you have to use is what we call a RMS value, or a root mean square value for your current. And that is going to be I sub 0, which is going to be your max divided by the square root of 2. And your root mean square for voltage is going to be V sub 0, which again is your maximum voltage divided by the square root of 2. Now you can look in a textbook for a deeper explanation of why it is over the square root of 2, but just in simpler terms, your actual maximum voltage in your house might actually be 300 some volts, but the 220 or the 110 that you've been told is actually the root mean square. Now, your power max would be IV, I0 times V0. But your power average has to use those root mean square values. So it's going to be your root mean square current times your voltage root mean square, which is going to be that crazy thing over the square root of 2 for each one. And what that turns out to be is just I max times V max divided by 1/2. That is our P average. Now as a problem, let's say that you've got this hairdryer, it's 950 watts, and you plug it into 220 volts, and they're asking you to find the maximum voltage, the maximum current, and the resistance for it. Take a minute, see if you can solve it using what we just learned. Pause it. And let's see how you did. So just to remind you what's going on, you've got this hairdryer that is here, and you plugged it into 220 volts, and it says that it's 950 watts. Now hopefully you should realize that's the average power. 220 volts, that's the RMS voltage that it's telling you. The actual voltage spikes and drops will be much higher and lower than that. Maximum voltage, that should be easy. We should call that V sub 0, and we know that V RMS is going to be equal to this V max divided by the square root of 2. So once you rearrange this, V0 is going to be square root of 2 times the 220 volts. That's going to give us a V max of 310. It's pretty high voltage, but it's only for, a split second. And then let's say we want the current. A few different ways you can do this. Maybe you want to find the RMS current first. So maybe you do P equals IV. And this is all RMS stuff. And you can still plug in the normals. The normal values you have 950 watts equals I times 220. That's going to give you an RMS current of 4.3 amps. Then you do the exact same thing that you did here, and you say that I RMS is going to equal to your Imax divided by the square root of 2. And you plug in your 4.3 amps right here. You solve for I sub 0, and you'll get an I sub 0 here of the much higher 6.1 amps. Then it wants you to find the resistance. You don't even have to use the RMS stuff. You can just use the very simple fact that R is going to be equal to V squared over P. Use all RMS, that actually be maybe the average power. And you can plug in your 220 volts squared divided by your 950. And you'll get an answer. However, keep in mind, you would get the exact same thing if you used your maximum values. So you could just as easily say that R is equal to Vmax divided by Imax. And you can plug in your 310 volts and your 6.1 amps, and you'll end up with 51 ohms. And that's the same thing that you would get if you use this. It doesn't matter which way you solve for it. All of this will come out the same.